Okay, so this is a mini lesson on solving equations with variables on both sides. Make sure you have your worksheet ready because we're going to take notes together. I'd like you to follow along with me. So some of you have been struggling with solving equations with variables on both sides because of the element of choice that these problems possess, because you have an option on the path you want to take to solve the equation. In other words, there's more than one way to solve the problem, and I think that's causing some issues and some indecisiveness here. So I wanted to break this down into steps. So the first thing you're going to do when you have a new equation that you want to solve is simplify each side of the equation. Some problems you'll have to do that. For others, it'll already be done, so you won't have to worry about that. But if you do, those are steps where you would be distributing or combining like terms. These occur on a single side of the equation. From there, the second step is to move the variables to one side of the equation. This is where the element of choice comes in. It does not matter what side you choose, but if you don't choose at all, then you're going to be lost. If you don't know where you're going, what your end goal is, you're going to have a tough time getting there. For the sake of this video, I am going to move my variables to the left side of my equation every single time. The third step is to move the constants to the other side of the equation. So whatever side you choose, your constants, the terms that just contain a number, will go to the opposite side that you choose your variable terms to go on. Finally, it says to solve the resulting equation. And again, anytime we're moving something from one side of the equation to another, we're going to be using inverse operations. That's very important. Otherwise, we'll be making some mistakes along the way. We won't get the correct answer. Okay, so problem A says 5x plus 6 is equal to 2x plus 5. Again, the first thing we're looking to do is see if we need to simplify anything. So I'm going to look on the left side of the equation. It says 5x plus 6. I don't see any place where I'd have to distribute or combine like terms. When I look on the right-hand side, it says 2x plus 5. Again, there's nothing to distribute. There are no like terms to the right of the equal sign. So now I move on to step 2. I'm going to pick the side that I want my variables on. Again, I'm going to always choose left for the sake of this video, so I want my variable terms on the left-hand side over here. That means this variable term 2x on the right-hand side is not in the place that I want it to be. So I'm going to use my inverse operations to make that move. Since this is a positive 2x, I'm going to subtract 2x on both sides of the equation. When I do that, those 2x's on the right-hand side are going to cancel, leaving me with just a 5 there. On the left-hand side of the equation, 5x minus 2x is equal to 3x. And I bring down my plus 6 term. Now I'm ready to move on to step 3. Move the constants to the other side of the equation. Again, I want my variable terms to be on the left-hand side. That's that 3x, so I have to move the plus 6. I'm going to use my inverse operation of subtraction. I'm going to subtract 6 on both sides. So on the left-hand side, I'm left with 3x. On the right-hand side, 5 minus 6 is equal to negative 1. Number 4 says solve the resulting equation. Well, there's a one-step equation remaining, so I have 3x is equal to negative 1. I'm going to divide both sides by 3 because I want the x to be by itself. 3 divided by 3 is 1, and I have x is equal to, negative 1 divided by 3 is not going to be a whole number, so I'm just going to leave my final answer in fraction form. So I'm going to write negative 1/3. I don't need a calculator for that. Okay, so that's our first problem. I'd like to move on to these other examples here. Okay, so problem B says 20y plus 5 is equal to 5y plus 65. So first, I'm going to check to see if there's anything I need to distribute or combine in terms of like terms. I don't see anything on either side, so I'm going to automatically begin moving my variable terms to the side of the equation that I want. Again, I'm choosing to move them to the left, so I need to move that 5y over to join the 20y. Since it's positive, I'm going to subtract. And again, what I do to one side, I have to do to the other. When I talk about sides, remember it's sides of the equal sign. So 5y minus 5y becomes a 0. On the right-hand side, all I'm left with is that positive 65. On the left-hand side, 20y minus 5y is 15y. And I'm going to bring down my plus 5 term. From here, this equation should start looking more familiar. You've solved two-step equations that look like this in the past. So we should be right back into where you're more comfortable working with. So I need to move this 5 over with the 65. There's an addition here, so I'm going to subtract 5 from both sides. 5 minus 5 is 0, so I'm left with 15y on the left-hand side. On the right, 65 minus 5 is equal to 60. Okay, so I'm left with 15y is equal to 60. That means I have to divide by 15 on both sides. And I'm left with y is equal to, well, 60 divided by 15 is 4. Problem C says 13 minus k is equal to k minus 7. Again, I check both sides. I can see that I do not need to distribute anywhere, and there are no like terms to combine. So I'm going to begin moving my variable terms to the left side of my equation. Over here on the right-hand side, I see a k here. Since it's positive, I'm going to have to subtract. So I'm going to subtract k on both sides. On the right-hand side, they will cancel, so I just bring down my minus 7 or negative 7. And on the left-hand side, I bring down my 13. And when I look at the terms on the left-hand side here, I have a minus k twice. So negative k minus k will give me a minus 2k. From here, the 13 needs to move to the right-hand side. It's positive, so I'm going to subtract. 13 minus 13 gives me 0. And on the other side, negative 7 minus 13 gives me negative 20. So I bring down negative 2k. Remember to bring the negative with you. And on the right-hand side, negative 20. Finally, I divide by negative 2. When I do that to both sides, I'll end up with k is equal to positive 10, because negative divided by negative gives me a positive answer. Problem D is negative 5 times the quantity of m minus 2 is equal to 2 minus m. This time, for the first example that we have on this worksheet, we need to distribute first. So I'm going to distribute my negative 5 to the m. That gives me negative 5m. Then I'm going to distribute the negative 5 to the minus 2. Now keep in mind that when you distribute a negative number to a subtraction problem, that's going to become a plus. And 5 times 2 is 10. Just bring everything else down. Now I do a quick check again. Do I have any like terms to combine? Here I don't, so I'm going to begin moving my variables to the left-hand side of the equation. There's a minus m on the right-hand side, so I'm just going to add m to both sides. Negative 5m plus m gives me negative 4m. Everything else comes down. So now I move my constant terms to the right-hand side. I'm going to subtract 10. So I'm left with negative 4m is equal to negative 8. All I have left to do here is to divide by negative 4 on both sides. M equals 2. Why don't you give the next problem a try on your own? Let's see how you did. So I notice on the right-hand side of the equation, I need to distribute the 2 to z plus 10. So I'm going to bring down my left-hand side just to stay organized here. And now I'm going to distribute. 2 times z is 2z, and 2 times a positive 10 is a positive 20. So I have negative 8z is equal to 2z plus 20. Now I need to move my variables over to the left-hand side. So I'm going to subtract 2z from both sides. On the right, they cancel. That was the point of subtracting the 2z, so I just bring down 20. And on the left-hand side, negative 8z minus 2z gives me negative 10z. Finally, I need to divide by negative 10 on both sides. And I'm left with z is equal to negative 2. I have one more example to show you before I would like you to do the problems on Go Formative. So I'm going to scroll down to problem F. Problem F says 3 times the quantity of 2x minus 1 is equal to negative 3x plus 12 plus 4x. I can see this time on both sides of the equation that there's some simplifying to do. So I'm just going to start from the left and work my way to the right. So I need to distribute my 3 to the 2x and the minus 1. When I do that, 3 times 2x gives me 6x. And 3 times a minus 1, well, that's minus 3. On the right-hand side, I see like terms. There's a negative 3x there as the first term, and the third term is a plus 4x. So I'm going to combine those two. Negative 3x plus 4x gives me positive 1x. I just don't write the 1. I'm also going to bring down that plus 12 term because we haven't done anything with that yet. At this point in time, I can see that both sides of the equation are now simplified. So I'm going to move my x over to the left-hand side to join the other. So I'm going to subtract x on both sides. The x's cancel on the right as planned, and I bring down my 12. On the left-hand side, 6x minus x gives me 5x, and I bring down the minus 3. From here, I need to move that minus 3 over to the right-hand side, so I'm going to add 3 on both sides. And I'm left with 5x equals 15. Finally, I'm going to divide by 5 on both sides of my equation. 5 divided by 5 gives me 1, so I'm left with x. On the other side, 15 divided by 5 is a 3. Now, before you submit your own problems into goformative.com, keep in mind that you have a way of checking your answers. Remember this. Just like you had for your last quiz on solving equations with variables just on one side, we can always take our solution and substitute it back into the equation to see if we get a true statement. I want to show that to you because I would like you to be checking your answers before you're submitting your graded problems. That would be a wise thing to do. I don't know about you. If I had a way of knowing if I had 100% or not before I submitted, I would definitely take advantage of that opportunity. So I'll show you here in the check. When you do your own checks, you don't have to necessarily do it on paper. You can do it in a calculator, but I just want to show you how it works out mathematically here. So if my answer was a 3, I'm going to go back to my original problem and I'm going to write everything, but everywhere I see an x, I'm going to substitute a 3 there instead. So this is 3 times the quantity of 2 times, we had 3 for our answer. So we're checking our 3. Keep it color-coded for you. Minus 1, that's on the left-hand side. On the other side, we have negative 3 times x. So negative 3 times the 3 that we got for our answer. Plus 12 plus 4x. So 4 times, we got 3 here. All right. So now we simplify. Order of operations. So I'm focused on the left-hand side first. We'll take care of that. I need to work inside the parentheses, and there's multiplication and subtraction here. I'm going to do the multiplying first. So everything else comes down. 2 times 3 gives me 6. Here's my new left side. I can also still need to do the 6 minus 1, so I'm going to do that here as well. That gives me 5. And 3 times 5 is 15. Again, you can put all of that in your calculator, hit enter, you get 15. You just have to remember the number that you get on the bottom. All right, so let's simplify on the right-hand side. Again, there's addition and multiplication going on. Order of operations says I need to multiply first. So negative 3 times 3 gives me negative 9. I'm going to bring down that plus 12, and at the same time, I'm going to do the 4 times 3. So 4 times 3 also gives me 12. I'm going to write plus 12 here. From here, I'm just going to work from left to right. So I have negative 9 plus 12. That gives me 3. And 3 plus 12 gives me 15. So I know that my answer is correct because when I substitute it into my equation, I get a true statement in the end.